everyone, and welcome to Lesson 7-4, Applying Properties of Similar Triangles. This happens to be one of my favorite lessons, where we're going to talk about 3 different theorems. So let's take a look at our first one. The first one is the triangle proportionality theorem. It says that if I have a line that is parallel to one side of a triangle, then what it's going to do is it's going to divide the sides of the triangle proportionally. And I really like this theorem because it kind of looks like a proportion. If the parallel lines make the equal sign, then I know that AE over EB is going to equal AF over FC. So it almost like sets up the proportion for you. So if the lines are parallel, then I can make that proportion and solve for any missing side lengths. Now, the converse of this says that if I make a proportion out of these side lengths and I see that they actually are equal, then I can conclude that the lines are parallel. So that's if I don't know the lines are parallel first. Remember, with any theorem and its converse, it's about what you know first. Okay, so let's take a look at an example. Okay, in example 1, they want you to find the length of CY. That's right here. So they've turned the triangle on its side, but you can still see these parallel lines. So see if you can set up a proportion and solve for the length of CI, then come back here and check your results. So what I did is I said 4 over 9 equals CY, or X, over 10. And then I did my cross product. 4 times 10 equals 9 times X. And then I divided by 9 on both sides. So X is 40 over 9, or 4 and 4/9. So that's the length of CY. Let's try another example. In example 2, they want us to verify that MN, which is this segment here, is parallel to KL. So this is the converse of the triangle proportionality theorem. So we need to set up a proportion and see if the fractions are actually equal. So see if you can do that, and then check your answer back here in just a minute. Okay, so what I did is I did KM over MJ. So KM is 21 and MJ is 42. And then I reduced my fraction. I did 21 over 42 is equal to 1 over 2. And then I did LN over NJ. Now notice you have to be consistent. If I did this part on top of this part, then I have to do this part on top of that part. Notice I did the left side on top of the right side. Now you could have flipped those fractions and that would still work, and you would just get 2 over 1 instead of 1 over 2. That still works. As long as you get the same fraction both times, then we're okay. So these two sides are divided proportionally. So the segments are parallel by the converse of the triangle proportionality theorem. And that's it for this example. So it's time for you to do a check it out question. So get a Google Doc ready. So you're going to do check it out numbers 1 and 2. In number 1, they want you to find the length of PN in this triangle. So you have to solve for that length. In number 2, they told you that AC is 36 and BC is 27. They gave you these other measurements in the pictures, and they want you to say why DE is parallel to AB. Now, it's really important to show your work on those, so be sure to do that, just like I did on example 2. So pause this video and do that on your Google Doc, and then come back for the next theorem we're going to talk about. The next theorem we have is two-transversal proportionality. And it says that if I have 3 or more parallel lines and they intersect 2 transversals, then those transversals are divided proportionally. So I can take parts of these and make fractions and say that they're equal. So AC over CE is equal to BD over DF. Now, this can get a lot of fun because if you have like 4 or 5 transversals here, I can do AE over some other side is equal to BF over another side. So you're allowed to combine these in unique ways. So it can get very interesting. Let's take a look at an example. In example 3, it says, an artist used perspective to draw guidelines to help her sketch a row of parallel trees. She then checked the drawing by measuring the distances between the trees. And they want you to find the length of LN right here. Okay, so what we're going to do is we're going to use the fact that all of these trees are parallel. We're going to create a proportion with the information that we know. So see if you can do that and solve for ln, and then come back here to check your work. So what I did is I said ln would be equal to BD, or at least proportional to it. And that leaves KL down here and AB up here. So I made some proportions. So I did AB over KL is equal to these two added together, BD over LN. Now you can make that proportion differently. So you can do like LN over KL is equal to BD over AB. So it's up to you how you want to make that, but your cross product is going to be the same as the one that I got. So here's my proportion with the measurements in it. I combined 1.4 and 2.2 to get 3.6. And then I did a cross product. So I did 3.6 times 2.6 equals 2.4 times ln. Here it is. And then I finished solving, and I got ln is 3.9 centimeters. So it's time for you to try one. In check it out number 3, you need to use the diagram to find LM, which is this segment here, and MN, which is this segment here, both to the nearest tenth. So do that on your Google Doc and then come back for our last theorem. Okay, the last theorem is a bit of a tongue twister, but let's see if I can get this. It's the triangle angle bisector theorem. Wow. An angle bisector of a triangle divides the opposite side into two segments whose lengths are proportional to the lengths of the other two sides. Now that's a little hard to understand just reading it, but what I like to do is right where they make our angle bisector, I like to think of it like it divides the triangle, and then I do AB over BD is equal to AC over DC. Okay, that's how I like to do it. Another way you could do it is you could do this side over that side. So BD over DC is equal to AB over AC. So there are lots of ways you can do that. I like to divide it at the angle bisector though. Okay, so let's take a look at an example. In example 4, they want you to find the length of RV, which is this segment here, and VT, which is this segment here. Now notice they did give us expressions for them, but they want the actual measure. So we need to create a proportion and solve for x, and then take that value and put it back in to find our measurements. So pause this video and see if you can do that, and then come back to check your answer. Okay, so what I did is I did 10 over x plus 2 is equal to 14 over 2x plus 1. I did my cross product, and I got this. I distributed the 10 and the 14. I subtracted 14x on both sides. I subtracted 10 on both sides. And then I divided by 6 to find out that x is 3. Then finally, I put 3 into both of these expressions, and I found out that RV is 3 plus 2, which is 5, and VT is 2 times 3 plus 1, which is 7. So that's it for this example. You have one more check it out question, and then you'll be done with this lesson. In check it out number 4, they want you to find the length of AC and DC. Now, this y over 2 is the same thing as 1/2 times y. So if you're more comfortable writing it that way, you can. But go ahead and try and do this on your Google Doc and then submit that doc. That's it for this lesson. So email me if you have any questions, and I'll talk to you soon.